Heating and air conditioning diagnosis. This video will use down-to-earth methods to demonstrate how to find the source of problems in today's automotive air conditioning and heating systems. It uses live-action video supported with interesting computer graphics to demonstrate how to inspect, troubleshoot, and analyze symptoms and problems. It covers basic inspection, checking control head and air door action, feeling and measuring line temperatures, listening for abnormal and normal sounds, as well as other techniques for finding troubles. The video explains how to use a digital thermometer, leak detector, and other specialized tools to make your troubleshooting more efficient. It also describes how to use a manifold gauge set to complete a performance test to analyze system operation. Normal and abnormal test pressures are detailed for both cycling clutch and expansion valve type air conditioning systems. This generic information will prepare you to troubleshoot heating and air conditioning systems for any make or model car or light truck. Always think safety when working. Refrigerant can cause severe frostbite. If it sprays out of a ruptured or loose fitting, it can produce painful burns to your skin and eyes. When liquid refrigerant leaks out into atmospheric pressure, it instantly begins to boil and vaporize and can freeze skin tissue. For this reason, always wear eye protection when working around an air conditioning system. Keep R12 away from excess heat. R12 containers can explode if they're heated by extremely hot water or by another heat source. Keep R12 away from open flames. When you burn R12, deadly poisonous phosgene gas is produced. Do not use older flame-type leak detectors in unventilated areas. Protect our atmosphere from harm. Never release R12 into the shop area. Use a recovery station. To begin your diagnosis of a heating and air conditioning system, verify the customer complaint. Make sure the control head in the dash is operating the air doors, compressor, blower, and other components normally. Turn the control head to maximum AC and feel the air coming out of the vents. After a few moments of operation, it should feel cold to the touch. Then, move the mode lever to normal and check general output. Move the fan switch to each speed to check blower action. This checks the blower motor, switch, and dropping resistors for trouble. Move the lever to the bi-level position. You should then feel air blowing out of the dash vents and out of the floor vents. If the bi-level mode is not working normally, you would know that something is wrong with the air door system that routes air through the ductwork. Make sure the heater is also working and that the control head routes air to the windshield in the defrost mode. This procedure will help you find problems in the control head, air doors, ducts, blower, and related components. A service manual will give charts like this one for each control head position. It will give part locations, air door positions, and arrows showing airflow for each lever position. This will help you find the source of a problem if air is not directed out of the vents normally. Again, refer to your service manual because it will give charts for each position and for the exact type of heating and air conditioning system. If the AC only fails to operate correctly in the max mode, look at the chart to determine how air should be routed through the ducts and how the air door should be positioned. Tests of the control head output, vacuum motor action, and mechanical levers would be required to isolate the trouble. Remember, this type diagram is particularly useful because it shows air door positions. Install a thermometer in a dash duct near the evaporator to measure exact air conditioning output. This will be needed if output is questionable, cool but possibly not cold enough. As indicated by a blue guide on this thermometer, temperature with the system on max should be around 35 to 45 degrees Fahrenheit. Check for a blown fuse if the blower or control head fails to operate. To begin your inspection in the engine compartment, check the compressor belt. It should not be broken, frayed, or slipping. Adjust belt tension if needed. Check the general condition of a fan clutch if used. It should have some resistance when rotated and not show signs of fluid leakage. To check for a bad water pump, wiggle the fan or pump pulley back and forth while watching for loose water pump bearings. An overheating engine could affect air conditioning system operation. Inspect the condition of the condenser. Clean out any debris that could block airflow through the unit. Check for bent fins and other damage that could upset normal condenser action. Blockage is common when a car is driven on country roads. An easy trick for finding a plugged or damaged orifice tube during your inspection is to shut the AC system down and listen for the hissing sound of an orifice tube. The hiss should last about 30 to 45 seconds before stopping. If it hisses longer, blockage is indicated. Another check. Make sure the compressor clutch is engaging and note how long the compressor stays on between cycles. Some cars still come equipped with a sight glass. You can inspect the sight glass to get a general indication of refrigerant charge. The sight glass is often located in one of the lines or in the receiver dryer. To read a sight glass, simply note the flow under the small glass window. A cloudy sight glass might indicate that desiccant or drying agent is circulating through the system. The receiver dryer or accumulator would have to be serviced. Oil streaks could mean excess oil has been added or could point to a low refrigerant charge. Excess bubbles or foam in the sight glass may indicate a low charge or air in the system. A clear sight glass either means the system has the correct refrigerant charge or it means the system is completely empty. An excellent way to analyze heating and air conditioning systems is to check line temperatures. With the heater on, the temperature of the heater hoses on both sides of the heater core and control valve should be about the same. If hose temperatures change, the heater core may be plugged or the heater valve may not be opening. Feel the air conditioning lines at the evaporator and accumulator to check general charge and operation of the air conditioning system. Low side lines should feel cool. The high side lines should feel warm. This would tell you that a refrigerant charge is circulating through the system. A digital pyrometer is an even better way to check AC system line temperatures. Here we are measuring high side temperature right before the orifice tube. As this animation demonstrates, the line should be warm on the high side of the orifice tube and cold on the low side of the orifice tube. Now we'll touch the digital pyrometer probe on the low side of the orifice tube. Note how the temperature drops, almost down to freezing. A typical reading would be around 34 to 38 degrees Fahrenheit. But again, line temperature can vary with ambient or outside temperature readings. Here we are taking a temperature reading on the outlet of the evaporator. It should also be slightly above the freezing point of water, or around 34 degrees Fahrenheit. Using a digital pyrometer to check the temperature of the condenser can find an internal condenser restriction. Generally, the temperature of the condenser should be uniform and only change a few degrees from top to bottom. If you find a sudden temperature drop at one location in the condenser, you have found a restriction inside the condenser tubes. The restriction can act as an orifice tube to cause a pressure drop in the refrigerant with an accompanying temperature drop. While you're using your digital pyrometer, you might also want to measure engine operating temperature. If an engine is overheating or running too hot, it can upset air conditioning action. If the engine is running below normal operating temperature, it can keep the heater from working normally. A bad compressor can make noise, be locked or seized, leak refrigerant, or produce abnormal pressures. Refrigerant lines can leak or become restricted, requiring replacement. A restricted accumulator may ice up, or its desiccant may have failed. The condenser can also leak or restrict flow. The evaporator can develop pinhole leaks and occasionally be restricted. The blower motor can go bad. The dash control head may not operate the air doors, compressor clutch, or the blower. Keep these problems in mind. An electronic leak detector is commonly used to find refrigerant leaks. It will make an audible change in tone when refrigerant is present. It uses an internal sensor to trigger an amplifier circuit to operate the speaker. An electronic leak detector is the fastest and safest way to locate system leaks. Here, we're checking for leakage around the compressor seal. This is one of the most common leakage points in an air conditioning system. Also check for leaks at line and hose connections. When leak testing, make sure you have an adequate charge of refrigerant and that the engine is off. Since refrigerant tends to settle downward, check under potential leakage points. Here we have found a hose leak. Note how the leak detector makes an audible signal when around the leakage. The evaporator is another common source of leakage. To check it, insert the probe into the evaporator housing. You can insert the probe as shown or next to one of the low pressure lines. Here we have found a small evaporator leak that would require replacement. You can also find evaporator leaks by testing at the vents in the passenger compartment. During operation, the electronic leak detector pulls a sample of air into the test probe and up into the tester body. If refrigerant is present, it will trigger the tester circuitry to make the sound change in tone or frequency. it is highly recommended over the older, dangerous flame-type leak detectors. To connect the manifold gauge set to the system, hang the set from the hood. Unscrew the hoses from the manifold and put on your safety glasses. Then, connect the hoses to the service fittings on the car. Here's the high side service fitting on one make and model vehicle. You must first remove the protective cap from the fitting, then you can install an adapter if needed, or the hose directly. If the service fitting is larger or smaller than the test hose fitting, you'll need an adapter like this one. Make sure the adapter has a valve in it to keep refrigerant from shooting out, or install the adapter on the test hose before the service fitting. Also, make sure the gauge valves are closed to prevent refrigerant loss. Then, screw the red test hose onto the high side service fitting. Again, make sure you're wearing eye protection. Snug the hose fitting down enough to keep it from leaking. Next, screw the blue test hose onto the low side service fitting. Route the hoses away from hot or moving engine parts to prevent them from being damaged. Now you're ready to do your performance test on the air conditioning system. The low pressure gauge is on the left. It measures suction side pressures on the inlet side of the compressor. The low pressure valve opens and closes the internal passage to the center hose. The low pressure hose is color-coded blue for easy reference. The center service hose leads out of the system. It can be connected to a recovery station, vacuum pump, or to a supply of refrigerant. The high pressure gauge is on the right. It measures pressure on the discharge side of the compressor. The high pressure valve opens and closes the system high side to the center hose. The high pressure hose is coded red and it connects to the discharge service fitting. Never cross up hose connections or gauge damage can result. When the valves are open, refrigerant is free to flow through the gauge manifold and out the center hose. After connecting the gauge set, bleed air from the hoses. Temporarily open the low pressure valve to remove air from the service hose. Crack open the high side valve so the system pressure can purge air from the high side hose. Close the center hose fitting to prevent loss of refrigerant during your performance test. Make sure that the gauge needles are zeroed. An adjustment screw is normally provided so that you can center or zero the needle when no pressure is allowed to enter the manifold. A performance test indicates system condition by measuring actual pressure with the engine running and the air conditioning set to max. Allow the pressure to stabilize for about 5 to 10 minutes. Measure and record the ambient or outside temperature in front of the condenser with a digital or conventional thermometer. Hold the probe about 1 inch in front of the condenser to measure ambient temperature. This will be needed when analyzing test pressures. Note how your outside temperature affects high side pressure. As temperature increases, system high side pressure increases. These are typical low side pressures for an orifice tube system. Again, they increase slightly as the outside temperature increases. Note the pressures for a typical expansion valve system. They are much lower than the orifice tube system and are also affected by temperature. Here is the low side gauge on an operating clutch cycling or orifice tube system. Note how the pressure increases to a preset pressure, then decreases. When the low side is increasing, the system or compressor is off. Then, when the compressor kicks on, the suction side pressure decreases. Refer to the factory pressure or troubleshooting chart for a specific make and model vehicle when analyzing pressure readings. Compare both low and high side pressures to factory specs for the ambient temperature. If low side pressure is low and high side is high, you can have a low charge, air or moisture in the system, faulty thermostat or pressure switch, bad expansion valve, or a high side restriction. If the high side and low sides are both high, you could have an overcharge, too much oil, obstructed condenser, or other problems. If the low side is high and the high side is low, check for a bad compressor, a restriction on the low side, expansion valve problems, or a high side restriction. The rate or speed of clutch cycling is also very important when using pressure readings to analyze system problems. If the high side is a little high and compressor clutch cycling is fast with short on-off times, it indicates a low charge. If the high side is high and the compressor runs continuously, air or an overcharge might be indicated. If the low side is high and the compressor runs continuously, a damaged orifice tube or leaking orifice tube O-ring is indicated. If pressures are normal, but the cycle rate is slow with long compressor on times, there may be moisture or excess oil in the system. If the low side is low with a slow cycle rate and long on-off times, check the cycle switch powering the compressor. If the low side is high and the high side is low with the compressor running continuously, you may have a bad compressor. If the low side is a little high and the high side is a little low with continuous compressor operation, a suction line may be plugged. If the high side is slightly low with a fast cycle rate, short on time and long off time, check for a plugged condenser, orifice tube, or line. When disconnecting your gauge set, wear safety glasses. Normally, remove the low side first, then the high side. Always reinstall the protective cap over the fittings to keep debris from entering the valves and possibly opening them. The other video in this set, titled Heating and Air Conditioning Service, will explain how to do pinpoint tests and replace specific components, how to recover used refrigerant, evacuate, as well as charge an air conditioning system. It will also summarize heating system service.